Good morning, students. Today we are going to see about the introduction for instruction set of 8085 microprocessor. So the instruction of 8085 microprocessor is something that it has an 8-bit or 16-bit data that may be directly given to the instruction set itself, and the address of the memory locations of input output devices and IO devices where the data resides may be given to the instruction itself. Okay, so in some instruction only one register is specified. The content of the special register is one of the operands. In some instruction they may specify two registers and the content of the operation of the registers of the required data. Okay, in some instruction the data are implied, and the most of the instruction of this type operate can be content of the accumulator. So due to the different ways of specifying the data for instruction, the machine codes of all instruction are not all same length. So it may be 1 byte or 2 byte or 3 byte instruction. So depends upon that your instruction sets are being grouped. Okay, the instruction are grouped in 5 groups, that is your arithmetic, logical, and third one is your data transfer, and fourth one is your bit manipulation, and fifth one is your string manipulation, and next one is your program execution transfer, that is branching, and last one is your process control execution. So let us see these things in detail. Okay, so first one is your arithmetic instruction. So your arithmetic instruction is your addition, subtraction, multiplication, and division, that is your arithmetic instruction. So this is a basic function of the register. So the instruction of this group performs an arithmetic operation such as addition, subtraction, increment or decrement of the content of the register or a memory. Okay, so here example, it affects in AF and CF, OF, PF, SF and ZF flags. Example, add AL comma 74H means the value of the 74 is added to the accumulator. Okay, so add DX and AX means the value that is stored in the AX register is be added with the values already which is in DX register. These two are an example of your addition operation. Okay, and next is your subtraction. So it subtracts a byte from a byte or a word from a word. Okay, this is your subtraction operation. So here it affects in the AF flag and CF or OF, PF or SF and ZF flags. Okay, for subtraction CF acts as a borrow flag, that is your carry flag. Okay, example, subtract AL comma 74H means where the value of 74 is subtracted with the AL. So subtract DX and AX means the value stored in the AX is subtracted with the value that is stored in the DX. Okay, this is an example of your subtraction. So SBB that represents that it subtract two operand and also borrow from the result. So it affects in the flag of AF, CF, OF and parity flag and SF and zero flag. Example, SBB AL comma 7H means the value that is stored, the value that is 74 is subtracted from the value that is stored in the AL. Okay, and similarly SBB DX comma AX is the value that is in the AX is subtracted with the value that is in the DX. So next, the third example is SBB AX comma BX. The BX represents the memory location of the stored number. So the number which is stored in that location is subtracted with the number which is in the AX. That it performs a subtraction operation. So multiplication. Next is your multiplication operation. It is an unsigned multiplication instruction that is represented as MUL CX. So it multiplies 2 bytes to produce a word or a 2 word to produce a double word. Okay, for example, if, the instruction is MUL CX. Okay, so AX is an location where it has some number that is multiplied with a certain value. This instruction assumes one of an operand of AL or AX, so that SRC represents the register or memory location, and flag of here auxiliary flag, OF flag and CF flag is your highlighted. Okay, unused bits of the destination register is always filled with the sign bits. So next is your division operation. So division operation, where it performs a division, and that is your div CX. So the value that is in CX is divided by the value that is in the AX. It is an unsigned division instruction, and it divides word by byte or double word by byte. The operand is stored in AX, so the divisor is SRX. The result is stored in the as the value in the AH will be your remainder, and the value in the AL will be your quotients. And similarly, the DX is your remainder, AX is your quotient. So it is signed as division instruction. So the last one is your CBW. It represents convert byte by word. The instruction that converts a byte in AL to word in the AX. The conversion is done by exciting the sign bit of AL through AH. So next one is your CWD. So the CW is something that convert word to the double word. So here the instruction that is in your converted word in AX to the double word in DX. So the last one is the conversion is done by exciting the sign bit of AX through DX. And next one is your increment and decrement. So INC represents that it increments a byte or a word by 1. The operand can be a register or a memory location. Example, you can represent as INC AX. AX represents your register value. Next is your decrement. Okay, it decrements a byte or a word by 1. So here in this, the operand can be a register or a memory location. Example, it can be represented as DEC into AX. So AX is your register or a memory location. Next is your comparative, that is CMP AL comma 74H, where the value of 74 is compared with the value that is stored in the accumulator. So it compare two specific bytes or a word. So here in this example, the SRC and DES can be a constant or a register or a memory location. So the both operands cannot be a memory location at the same time. The comparison is done simply by internally subtracting the source from a destination. So next one is your 2's complements. It creates a 2's complement of the given number. That means it changes the sign of the number. And next is your DAA. That is your decimal adjust after addition. It is used to make sure that the result of adding two BCD numbers is adjusted to store a correct BCD numbers. It works only with the AL register. So for subtraction, for addition we used to include DAA, and for subtraction we used to say as DAS. So this is an example for your decimal adjustment of after subtraction. So here is your assessment question. If just work out with this, and if you have any clarification, contact me. Thank you.